Hello, in this video we're going to take a look at the first lesson of our last unit, which is geometry, and today is all about angles. In today's lesson, it's a lot of vocabulary. We're going to be learning the parts of the angles, how to name angles, the different type of angles and triangles that exist, the sum of angles in a triangle, and the difference between a complementary angle and a supplementary angle. As we begin, you may want to use a note sheet, and I provide one in the email to you to help you with all the vocabulary. So you may want to take notes as you go through the video so that you can refer to those notes at a later time. We're going to begin with rays. So this AB is a ray, and a ray is defined by having an endpoint on one side and an arrow on the other side. So that means that we have a stopping point, and that can be either on the left or on the right, it doesn't matter. And then the arrow indicates that this line will continue in the direction forever. When we put two rays together and we connect them, we make an angle. And here is our angle. And the connection between the two rays is called the vertex. So two rays that form an angle meet at the vertex, and in this case, the vertex is angle B. When you'd like to name an angle, you can name it in two ways. So we're going to call this angle, and this is my angle symbol, and the vertex is always going to be the middle letter. So we can either look from top to vertex downwards, so this could be angle ABC, or we can look upwards from the bottom up, angle CBA. Either one of these answers is perfect because the vertex is in the center and we can read the angle in different directions and still be correct. We can name angles or put them in categories based on how large or small they are. The first one is our small angles that are less than 90 degrees. So 90 degrees is an angle where we have a perfect corner. So we use that as our reference to determine the other angles. So this angle here is 45 degrees. It's a small angle, and we call that acute. And you may remember that because cute things are often small. A right angle is exactly equal to 90 degrees, and you have to know this by a box in the corner. So if you are not given the right angle symbol in the corner, you cannot assume that that angle is right, even if it looks like it. So we have that box in the corner, and that indicates exactly 90 degrees, and that is our right angle. Obtuse angles are greater than 90 degrees. Again, the reference here is that 90. So we see that this angle is far greater than that. It's 120 degrees. That is an obtuse angle. And then the straight angle is where we would swing that back and we actually have a line. So we don't have two rays forming. We have a line that extends in both directions, and that makes 180 degrees. And a full circle, if we were to draw an angle on the other side, full circle is equal to 360 degrees. And that's going to be important for us to know for future lessons. When we have an angle like we named angle ABC, we're often looking for that angle B on the inside. But we can also determine the outside angle if we know what angle B is. So again, that 360 will help us to be able to determine. And so that outside angle is called a reflex angle. It's greater than 180, but less than 360. And the way I remember a reflex angle is thinking about going to the doctor's office and the doctor hits your knee to check your reflexes. I remember this one because of the doctor banging my knee on the outside. Often in math, when you are working with angles, you measure using a protractor. In this course, you do not need a protractor. We will not be measuring using a protractor. We're going to be calculating angles. But if you wanted to measure any angle, what you would do is you would line it up so that the vertex was lined up right on this line of your protractor. And we can see that this is an obtuse angle. So we would line up one side on 0, and we would check where the other side falls. And because it's an obtuse angle, we know that the second measurement, the 140 degrees, is the correct one. And the 40 degrees would be an angle on the other side here. This would be the small portion, because 140 and 40 make 180. So that's the quickest lesson ever on protractors, but like I said, we won't be using a protractor in this course. On page 412, there's some practice for you to be able to name your angles. So it's a good practice now to take the time to name your angles as either right, reflex, straight, obtuse, or acute, and then you can check your answers in the answer key. Let's talk now about triangles. Triangle means 3 angles, and where you have 3 angles, you also have 3 sides. And we name triangles according to the type of angles that exist in the triangle. So we first have right triangles. If a triangle has a right angle, and again, that has to be indicated by the box in the corner, a 90-degree angle, then we call this a right triangle. Also notice that this right triangle is going to have 2 acute angles in there because they're smaller than 90 degrees, and in all, we're going to have a total of 180 degrees for this right triangle. We can classify a triangle as obtuse if it has 1 obtuse angle in it. So we can see this one has 158 degrees. We see that we have 2 little acute angles there for this triangle, but 1 obtuse angle, so therefore it's an obtuse triangle. Acute triangle has to have all angles less than 90 degrees. We will see this example for here and here and here. We have an equilateral triangle, or what looks to be an equilateral triangle. Actually, it isn't, because the top one is 65 degrees, so we have 2 other acute angles here in the corners. We don't know what they are, and we don't actually know if the side lengths are the same, so forgive me for that. So we don't quite have enough information to figure out these other 2 angles, but we can definitely see that they are acute angles. So therefore, this is an acute triangle. So now we see the last kind of triangle. This one is the equilateral triangle. So this one's labeled for us. So we have all 3 angles, all the same. They're all equal. And actually, that means that all 3 sides are equal as well. And we can show that here. I'm using these ticks. Single tick indicates that every side is the same, because every angle is the same. So this is equal in all ways. This is your equilateral triangle. Earlier, we saw a triangle with 65 degrees at the top. And I wasn't quite sure, but that one I think was an isosceles triangle. This one is definitely an isosceles triangle. And how do I know this? Well, the definition of isosceles means we have 2 equal angles, therefore 2 equal sides. So we see down in the bottom, we have a 70 degree and a 70 degree angle down there, and a 40 degree up top. This one's acute. Every angle is smaller than 90, but it's also defined as isosceles because 2 of the angles are the same. The last kind of triangle is scalene. Scalene triangles have no equal angles. So you'll see that all 3 of these are acute, 80, 30, and 70, and all three angles add up to 180. And that's the same for any triangle shape or size. All three angles will always add to 180. And here we see none of them are the same. Therefore, we classify it as scalene. When you're to name triangles, you can name them two ways. So you can see here for the first student example on page 407, we have a right triangle, but we can also classify this one. If I were to indicate here that two of the angles were the same, we could classify this as isosceles if we knew that both of these angles, for example, were 45 degrees. We don't know this for this one, so we can just call it a right triangle. But if we knew that both angles on the other sides were the same, we could call it also isosceles. For the second example, we see we have 65 degrees up top. We can see that the angles down below are smaller than 90 degrees. So those are also acute. So this is an acute triangle. And see, we have one large angle. We don't know what the small angles are. We know they're acute, but the big one is obtuse. Therefore, this is an obtuse triangle. For D, we see we have two angles and therefore two sides that are the same. I can never spell this word right. This is your isosceles triangle. And the bottom one has those three different angles. That means this one is scalene. Lastly, let's talk about complementary and supplementary angles. Complementary angles are two or more angles, so it doesn't only have to be two, but they have to add together to make 90 degrees. So we can see that these two angles here, the 65 degree BDA or ADB plus BDC at 25 degrees or CBD, these two make a right angle, and so they're complementary. The way that I remember this is the word corner. They make that right corner. When you have a missing angle, like angle Y, but you see that it shares the right angle with 15 degrees, you can then solve by taking the 90 degrees and subtracting the 15 degrees. So therefore, Y is equal to 75 degrees. For the student example, you're going to draw and label a right angle. That's called WYX. Then you're going to draw and label WYZ as 35 degrees and draw and label XYZ as the complement of 35 degrees. Go ahead and draw these, and then you can check the solution. Here's an image. You may have drawn it this way. WYZ is 35 degrees. Whereas XYZ or ZYX equals out at 55 degrees, we take the 90 from the corner because of the word complement, and we subtract 35 from 90 to get that 55 degree missing complement to 35 degrees. Lastly, let's look at supplementary angles. When I see supplementary, I think of straight, because these are two or more angles that form a line, two or more angles forming 180 degrees. So we can see DEF and FEG, they're making 180 degrees together. They are supplements. When we see this student example, we see we have 78 degrees sharing a line with W. So we can determine W by taking 180 and subtracting 78 from there. And we can see that W is an obtuse angle at 102 degrees because we understand they are supplements on a line forming a total of 180 degrees. You should now be ready to try the exercises on page 412 and 414. and best wishes for your angle notes for this first lesson.